Now, okay, now we're recording. I'm going to go back and do a question dealing with limiting reactants. Okay, let's take our time with it. I'll tie a couple of other questions in with it. This will be kind of an exam review. And then we'll move into Chapter 4, which will not be on this test. Okay, that'll be on the next test. But we have to keep moving forward, though. All right, so if there aren't any other questions then, let me get this over here. And I'll put a reaction on the board. Let's see. I guess that should do it. Okay, we're going to have 4 HCl aqueous plus MnO2. Now, how's this for a review question? MnO2, what kind of compound is it and how would you name it? I heard ionic. Who said ionic? Well, you can fess up. You were right. Now the hands go up. Okay, ionic. And what would you call that compound? What's that? I see a lot of lips moving, but I don't hear anything. Manganese, what? Manganese 4 oxide. Okay, it took 3 people to put it together, but get together after class and compare notes. Okay, manganese 4 oxide. Okay. Let's see. That's going to be. Okay, have that down as a solid. And then we're going to have. If you got that one, you should recognize this as manganese 2 chloride or 2 chloride. Right. Excuse me. And yes, my phone is ringing, but I can't get to it. I should leave it out because I said if there's an emergency in the lab, since I oversee the labs as one of my wonderful jobs, it could be an emergency. So, but that emergency went unanswered. Okay, so let's see. We all on the board here? Good, excellent. Okay, now I'll give you some more information here. Hydrogen, since this isn't up there on the board, 1.02 grams per mole. Chlorine, 35.45 grams per mole. And let's see what else we got. Manganese, that's going to be 59.94 grams per mole. And oxygen is going to be 16.00 grams per mole. All right. Now let's have 50 grams of the hydrochloric acid and 50 grams of the manganese 4 oxide. You guys work together. You can work by yourselves if you want. In fact, try it first by yourself. If you feel kind of uncertain, you can lean over to your neighbor and start comparing notes. But based on that, I want you guys to find me the limiting reagent. Okay, that's the first thing. The second part is going to be finding the yield of manganese. Write it like this. Find limiting reagent, and then find mass of manganese 2 chloride produced. Okay? Just go to work. Let's see if you can do it. This will be a good review. Get out those calculators. And I'll just kind of walk around here for a few minutes. Double check to be sure the equation is balanced. I gave you a hint, it is balanced properly, but still just check it for an exercise, just to be sure. Let's take 5 minutes to do this. Better. What's the first thing we should do? What's the first thing we should do? Any thoughts? What's the first thing we should do? You gave it away. Okay. Good for you. You lost your voice. We'll look for it after class, okay? So as the gentleman said, first convert to moles. Okay? And you guys know how to do that, don't you? Excuse me. Okay, what do we have for molar mass for hydrochloric acid? Yeah, 35.45 plus 1.01. 36.46 grams per mole. Okay, now we have manganese 4 oxide, and what's the mass of that going to be? This might sound trivial, but make sure everybody knows how to go through the basic drills. Manganese 4 oxide, what do we have for a molar mass? What was that? 91.94? Okay. Once again, we just get back to adding 59.94 to 2 oxygens. That's 16 apiece, so it's 32 plus that. Okay, so 32, that's going to give us 91.94. Oh, that's right. I'm sorry. Yeah, I'm sorry. Only had 3 sips of coffee so far. All right, so let's get the last 2 up here. Manganese 2 chloride is going to be what? Somebody else? Anybody? You, sir? With the white sports jacket? Is what? The manganese 2 chloride. Anybody else? 130? I can't hear you louder. 130.84. Okay, everybody double check these numbers to be sure. Okay, then finally, I'll actually have 2 more here. H2O. Is that right? 18.01? 18, oh, I'm sorry, 02. Okay, and let's get one more up here. That's going to be the chlorine, which is going to be 35, 35, 40. It's going to be 70.90. Okay. If somebody doesn't know how to do this, they should really get back into the books and notes and figure out how to do it. Come and see me if you need to. But, like, I'm going to go through all this stuff right now. Okay, excuse me. Let's move this camera over a little bit. About to there should do it. All right, so now we're going to take 50 grams of HCl and 50 grams of MnO2. So we're going to have 50 grams HCl times, and what's our conversion factor going to be? That's right. You put moles up on top, okay, and it's going to be, where are we right here? 36.46 grams. And what does that give us as an answer? Once again, louder. 1.37. Okay. Grams of HCl are going to cancel out. That's 1.37 moles of HCl. Okay. 50 grams of MnO2. Oops, sorry about that. That's going to be 1 mole of MnO2 over 91.94. 96? 96? Manganese 4 oxide is 91.94? What? Yes, thank you. Okay. All right, and what's our answer here? 0.54 moles of manganese 4 oxide. Okay. Now we have to determine which of those two. Now I know we put them all down here, but that's kind of a drill I gave you just so you could, see if anybody had problems doing that. What I'd like to do now is determine which is in excess and which is limiting. So we have a ratio up here. We go back to our balanced equation. You can see our ratios are going to be 4 chlorides to 1 manganese 4 oxide. So if some of you can just do it by inspection, that's really fun. That's nice. But what I'd like to do is just do the calculation. So let's put this off here. And what I suggest is do this. You can choose either one. You can choose the HCl or the MnO2. It doesn't matter which one, what I'm about to do. What I'm going to do is take the HCl and find out how much MnO2, how many moles of MnO2 are going to be needed. Okay, you could have gone the other way. You could take the MnO2 and find out how many moles of HCl are needed. Okay, it doesn't matter. but I'll just take HCl because I feel like it today. So I'll take, let's see, what do we got here? 1.37 moles of HCl times, now our conversion factor, we're going to be comparing the 4 moles of HCl to the 1 mole of MnO2. Okay, did I move the camera? Yes. So put moles of HCl underneath so they cancels properly. Moles of MnO2, and we're going to have 4 to 1. Okay. I guess I should do this with you guys. 1.37. Oop, didn't come through there. Let's do that again. 1.37, and divide that by 4. Okay. I'll put the answer here. Okay, it's going to be 0.343 moles of MnO2 needed. Okay? Does everybody follow what I just did? Are you okay? Okay, good. All right, so let's look at this. With this many moles of HCl, which is what we're starting with here, we're only going to need 0.343 moles of MnO2. And check my answer to make sure, I didn't hit a wrong key or something. Here's what we have, 0.54. We have more MnO2 than we need. Okay, therefore the MnO2 is in excess. Remember, 100 slices of bread, 4 slices of cheese. Okay, the MnO2 will be the slices of bread this time. Okay? So we have excess MnO2. Therefore, the HCl is going to be our limiting reagent. Okay? LR, limiting reagent. Okay, now how do you go about finding out how many moles or grams of MnCl2? How do we proceed now with the rest of the calculation? If anybody has any questions, believe me, this is a very, very, very good time to raise your hand and ask me. I really don't mind going over it again. Yes, sir. Why didn't we take up here, you mean? We could have. I told you. We could go with either one. Okay. You'd get not the same number as an answer, but you could see which one was in excess. It would be the same for both. Okay. You'd find out if you did it the other way that you didn't have enough MnO2, which means that would be limiting. Yes. Question? Yeah. You can see here from the balanced equation, we have, it takes 4 moles of HCl for this reaction to go to completion. Only 1 mole of MnO2, 4 to 1 ratio, right? Let's see, who asked the question? I'm sorry, right there. Okay, so you say it's 4 to 1. So if we had 8 moles of HCl, how many moles of MnO2 will we need? Yeah. See, right in your head, it's that simple, right? Okay, now, this is the game they love to play about limiting reactants. And I've told you before, as a chemist, you won't have to sit here and back calculate. You determine yourself what you want to limit the reaction with. I went over this Friday. But this is just kind of an exercise to make sure you understand thoroughly about how to balance equations. It's just a thing in logic. Like if you don't have too many slices of bread, not enough cheese, how much can you make? It's the same thing here. Remember that example I gave you about making sandwiches? Okay, so the way this type of exercise is usually introduced to the class is that they just give you grams of both, and you have to figure out which one is in excess and which one is limiting. Okay, in other words, what we did here was determine that with 50 grams of HCl, that is the same thing as 1.37 moles of HCl, correct? Okay, so now we just do a calculation here to find out for these many moles of HCl, how many moles of the MnO2 are we going to need? Okay? We're only going to need 0.3, correct? See the calculation? However, we have 0.5. We have more MnO2 than we really need. Therefore, the MnO2 is in excess. In other words, when the MnO2, we have more than enough MnO2 to chew up all this HCl and making product. As soon as this is gone, we stop making product, or stop making sandwiches if you want to go back to that. And we will have some MnO2 left over. Well, what do you think? 1 second, please. Was that good?
Yeah.
Feel good? Yeah. All right. Now in the back, yes.
So if you did it the other way, say you found like MnO2, how much MnO2 is in HCl, would the number be bigger than your 50 grams of HCl?
If you start it with, if you look for the Mn, if you did the same calculation, let me see, okay, with the MnO2, well, what do you think would happen here? Okay, this is the number of moles of MnO2, right? Well, the HCl required is going to be more than this if you do it the other way. Okay, and when you get back and look at your number, you say, wow, I don't have that much HCl, I only have this much. Well, just try working the calculation that way and see what happens. When you look at the two answers, you'll see that they give you the exact same information. Okay? Any other questions? All right. Now, who wants to tell me, how do we find out how many moles of MnCl2 that we're going to make? How do we go about finding that now? Yes?
By stoichiometry.
What?
By stoichiometry.
Well, yes, but which reagent do we use?
We use the limiting.
We use the limiting reagent. Use the stuff in excess. It doesn't make any sense. Like I said, 100 slices of bread, 4 slices of cheese. You can't make 150 sandwiches. You can only make 4. The cheese is the limiting reactant. When that's all used up, you still got a lot of bread left over. Okay? When the HCl is used up, we stop making product, and we have MnO2 left over. You guys okay with this? Okay, and like I said, in the book, he uses what we call an ice table, which you'll use in it's not called an ice table, but it's based on that structure. You use that in equilibrium calculations, and I don't think you have to go that far with this. I know you don't. It's a nice thing to see, but I think these calculations are a little more straightforward myself. But look at the book and see how he presents it. Maybe he'll help you. I don't know. It's hard to say. Okay, so let's finish up this calculation, folks. Let's see. Come this, wrong way. Come this way. There I am. Flip. All right. Okay. All right, so now what we're going to do is we're going to use the HCl. That'll be our limiting reactant. Okay. So we'll have 1.37 moles HCl times. Now going back to the balanced equation, we are now looking at the relationship between the HCl and the MnCl2. So right now we're going to interrelate these two guys. The start of the problem, it was these two. And now it's this guy, the limiting reagent, and the one of the products that I asked for. Okay, let's come back this way now. All right, there we go. All right, so we will put moles of HCl underneath and moles of MnCl2 on top. And it's going to be a 4 to 1. Okay, moles of HCl will cancel out. And we'll take 1.374. Excuse me, I'm sorry. And, here's our answer right here. It gives the same answer, 0.343, 3 moles of MnCl2 produced. Okay? All right, and the last part is just kind of window dressing. Let's just put it into grams anyway. 0.343 moles MnCl2 times, and we'll come back here, one of the calculations we did, 130.84. And that's going to be grams per 1 mole. What am I doing? Got it upside down. 130.84 grams per 1 mole. Bless you. You're welcome. She didn't say thank you. Let's see. Where did I put? Oh, here it is. I was erased the board with this thing. Uncool. Let's see. Okay, let me clear that. There you go. 0.343 times 130.84. And I come up with 44.88 grams of manganese chloride. All right? All right, let me give you one more piece here just to keep it really, really fun. Let's see. We'll say actual yield. Let's say it was 35.21 grams. Now, while I push this board up and bring another board down, you guys give me the percent yield. It's trivial now. Yes?
That's the question. What made, how do we tell which ones are living reagent? I thought I understood how kind of what you were.
You thought you understood, but what?
I thought I understood what means excess reagent, but what made HCl our living reagent and
Okay. First of all, as I said, if it doesn't confuse anybody, arbitrarily I said, let's do this calculation based on the amount of HCl we have. Let's find out how much MnO2 we need. Like, we know we have this much, but let's find out how much do we actually need. Okay? So that's what this was about here. Given 1.37 moles of HCl, okay, we have a 4-to-1 ratio from the balanced equation. We only need 0.343 moles of manganese fluoroxide, right? Okay, but we actually have 0.54. So we have more than we actually need. Ooh, I'd love to see that light bulb go on. It's so nice. You really got it? Okay. Yeah, and you always use your limiting reagent. If you guys understand this, it should be fine. I mean, if you understand the basic concept, that's the whole thing. You need to memorize how to do these problems, but if you understand the concept behind it, you'll be way ahead. Less memorization, more just problem solving. Right? Am I right? Yes, I am. Okay, good. All right, so let's get this board up. Let's get the other board down. Just 1 second, please, while I put the board up and put this board down and move my camera. And as I move the camera, you can ask your question. Yes?
I have a question on the other board.
Well, the other board's up in the air now, right? This board?
Yeah.
Okay, so what's your question?
I'm confused on the last precept you said. Like above the actual.
Yeah.
I'm confused on why you did that.
Well, because I asked you find the mass of the MnCl2. Did I use the MnCl? Yeah, I did. I asked for the mass of the Wait a minute. Find mass of MnCl2 produced, right? So we know that we produce 0.343 moles of MnCl2. Is that correct? See the top there? So we come down and using the molar mass from MnCl2, I found out how many grams of MnCl2. I'm sorry, couldn't I? What? Yeah. When you say mass, is that what you're saying? When I say mass, I'm talking about grams. Yeah, when you say mass, grams or kilograms or milligrams, whatever, depending on. I just made that up. Remember what an actual yield is? I leave you guys here. I run down to my laboratory with. What's wrong with that? I can do that if I want. I'll take my coffee with me too. I'll run down the hall with 50 grams of HCl, well, in a tight bag, of course, and I'll run the reaction. Water in the corner. There we go. All right. I run the reaction, and I come back, and you guys are still sitting here tapping your fingers, and I say, oh my God, I only got 35.21 grams. Then I said, oh, okay, well, we have a theoretical yield, right? And what was the theoretical yield? There you go. I only got less than that. So we have an actual yield and a theoretical yield. We went over this on Friday. And so come up with a percent yield, right? Theoretical is what you calculate on paper. You haven't even seen a laboratory. You just calculate it. That's 100%. In real life, we never get 100%. What's that? Yes, whatever you calculate, that's theoretical. It's on paper. Now, did I lose this thing? Just to make sure I still have my recording going here. Hopefully, I do. Good. All right, so real quick, this shouldn't take too much longer now. Percent yield is going to be actual over theoretical times 100. And our actual yield was 35.21 grams. And our theoretical yield was 44.88 grams. And somebody tell me the answer. Oh, all together. But try practice these things before class, okay? What was it? 78.5, right? Okay. Oh, thank you. 78.5? Is that what you said? Okay, we're holding you responsible. All right, 78.5%. Okay, one more question here. Let's see, find percent manganese in, there you go. Let's do this one real quick too. The reason I'm just not putting this stuff on the board because I want you guys to see if you understand it, work it. Has anybody actually used these videos to review the lecture yet? I'm just curious. What'd you think? Quality okay? I mean, there's no commercials, I'm sorry, but yeah.
Where on Blackboard are they located?
Yeah, you just, when you go up to the Blackboard site for the class, it's over in the left-hand margin. It says Tegrity Classes. Just click on that.
Percent by mass?
What?
Percent by mass?
Yes, it is. Percent by mass. It's okay. Yes. I'm sorry, a little bit louder, sir. Well, when the CSU truant officer knocks on your door. I'm kidding. Yeah, you're allowed to stay home if you want. Yeah, I'm just being funny. I'm not going to take attendance, sir. Okay, so have a sense of humor about this. That's what I do. But yeah, you can stay home. Now, I talked to him, and he says, the way I set it up, we should be able to stay home and watch a lecture. I don't know if you have a volunteer to try it sometime. But don't do it on Wednesday, because that's the exam day. But yes, somebody give it a shot, or get a sore throat, stay home, and then tell me if it works. Okay, ladies before gentlemen, yeah? Oh, stop laughing. What? Yeah, well, you do that, but I'm saying is they told me that, they first told me we couldn't watch it at the exact same time, real time, but then he called me back and said, guess what, I was wrong, you can. And then I set the thing up and he said, well, it should work, but I can't stay home and watch myself, so if anybody does it, let us know if it works. You just go in, you should be able to just tune right into the lecture, yes?
Yeah, before class I had it up on my phone, and it won't let you watch it on your phone and use the service. It has to install some file, but otherwise
Yeah.
it was up and running, it said now live. So.
Yeah, well, if you carry a PC and a monitor with you at all times, you should be in good shape. All right, let's get on here, guys. We got a few minutes left here. We got to finish this stuff up here. Okay, so we're going to find the percent. Everybody, I know we're having a good time. It's chemistry, but you got to keep your feet on the ground. All right, so how do we do this? Any thoughts? How about you? Yeah. Yeah. All right. She's got a good idea. Let's try it, see if it works. Okay, manganese. Manganese, manganese, manganese. It's right, where did I put it? Oh, there it is, 59. So you take the mass of the, come on guys, keep it down. I can hear you way down here. Okay, does that look familiar? Yeah, times 100. Manganese, like, you don't worry about the balanced equation now. Don't go there. We're just talking about, take manganese, 4 oxide. You got it in your hand looking at it, all by itself, no chemical reaction. What's the percentage? Some people, they come back to the balanced chemical equation sometimes for not very good reasons. Okay, so let's see, that's going to be 59.94 grams of manganese over, let's see, the manganese 4 oxide, 91.94 grams manganese 4 oxide times 100. And somebody yell out the answer. But you never do it at the same time. That's the trouble. It sounds like a wave breaking on the beach. What? 65.1. Is she correct? No? What did you get? You better not come back. What was it? What was it again? 65.2%. And if people disagree, she's right there. Okay? Take her to task. All right, guys. Yeah. Oh, significant figures. Okay. Yeah, we had 4. Well, yeah, okay. It's her fault. Okay. How's that? So where was I? Yeah. For the exam, you got to go back, review all that nomenclature, all that good stuff. Okay? Let's do it. All right. Videos, I got to put the label on last Friday's, the title, and then I get this one up. You know, let me know later if these work. And we've got 10 minutes left, so let's take our parachutes off. Okay, relax. Sit back, finish your coffee. And what I'd like to do right now is start into Chapter 4, which will not be on the test. And I know I'll get email later saying, will Chapter 4 be on the test? No. Okay? Excuse me. All right, now Chapter 4, these are chemical reactions. There's only about 3 of them they look at here. And they're all aqueous. Now he has, I think, a little bit too brief an introduction on this stuff. So actually, since we have 10 minutes, we can kind of relax into this chapter. Yeah, we talk about solution chemistry here. Okay, and what's the definition of a solution? What is a solution? Don't tell me an answer. What's a solution? Yes, sir. No, see, this is good for exam also. We have solutions, and a solution basically is what? A what? I heard somebody say it, what? Homogeneous mixture. Get this stuff going. I know you got a lot of other courses too, and it's hard to kind of keep ahead of everything. But go back and try to review them. Just skim through your notes sometimes. Just keep it fresh. Yeah, a solution is a homogeneous mixture. Now, what we're going to do is we're going to look into a solution and take it apart. So we have a solution. A solution has 2 main components. It's going to have a solute and a solvent. the solute is dissolved into the solvent. Okay? And sometimes you can just, if I say salt water, what do you think the solute is? The salt. You're not basically dissolving water into salt. Okay? So we've got our solute and our solution. Now, do you have to have just one solute? No, you can have 15 solutes. It doesn't matter. But there's something that is dissolved in that we label. If you have two liquids that are miscible, okay, like let's say rubbing alcohol, isopropyl alcohol, and water. Okay, well, when you have two liquids, you say, which one is the solvent? Well, it turns out the one that is usually in greater amount. Am I correct, Dr. Goganaya? Yes, he agrees. Okay. He's keeping score on me right now. I think I'm up to about an 86% or something. Yeah, good. Lighten up, guys. Come on. We got a big week ahead of us here. Yeah, the one that's greater amount when it comes to liquids, you can have gas solutions, all that type of thing. Okay? So anyway, we got the solute and the solvent. And let's see. Yeah, let's start in regards to the solutions. Let's talk about electrolytes. Okay? Now, electrolytes basically, they dissolve in solvent, in this case, water. Okay? So we're talking aqueous solutions at this point for all these reactions also. When you get to organic chemistry, then you kind of get into non-aqueous solutions. But let's not worry about that now. Okay? So all these will be in water. Electrolytes, well, what's the term come from? Well, how about the idea when you dissolve these electrolytes, they conduct electricity. Okay? So that's basically what we're getting to. We talk about electrolytes in our sports drinks and all that type of stuff. Okay? They're basically ionic species that dissociate. In fact, let's just look at this right here. Electrolytes, we will say they dissolve and dissociate in water. Now let me just give you an idea here of what I'm talking about when I say dissolve and dissociate. If you were to take a very basic one like sodium chloride, okay, now he does get into this in the book. Like I said, I think this is just to kind of help you understand things a little bit better. Solid. Let's put that into water. And now we'll have something that we write like this. Sodium chloride aqueous. Now what exactly does aqueous mean? Okay, that means, I'll say aqueous, we can think of it like this. You'll have your sodium ions surrounded by water molecules. Okay, there's actually interactions, electrostatic interactions. You'll have like force surrounding it, one in the front, one in the back, like six, an average of like 6 water molecules per sodium ion. And for the chloride ion, be the exact same thing. Just like this. Okay? So the thing is, when you have NaCl aqueous, they mean that the NaCl are totally dissociated and surrounded by water molecules. Okay? And this is where you start carrying charge. Okay? When this kind of thing happens. If you put a covalent compound into water, I'll talk a little bit more about this a little later, it will dissolve in water. Like methanol will dissolve in water. But it does not dissociate. Okay? It's surrounded by, well, it has water molecules around it, hydrogen bonded to the OH, that type of thing. Not to this extent, but still. It will have interaction with the water molecules, but it does not dissociate. Okay? When you get into equilibrium next semester and all that kind of stuff, you know, you might see this minor dissociation, but nothing that's really going to conduct anything. But anyway, that's the term aqueous, what we're talking about. It's dissolved and it's dissociated. Okay, so when you see aqueous, and in fact in this chapter you're going to have to kind of visualize what happens to chemical reaction in water, what dissociates, what does not dissociate. Okay, so I just want to kind of give you this introduction here. We got about 2 minutes left, and that's a good time to leave. See you guys on Wednesday for the big exam. Don't stay up too late studying. Let me just shut this off.
Sometimes I forgot the first.